Hello, this is Mr. Stansbury. I'm going to take you through the notes on the common logarithm function. At the end of this, you should be able to say, I can evaluate simple base 10 logarithms without a calculator, and I can rewrite exponential equations as logarithmic equations, and vice versa. Okay, so first things first, a logarithm. A logarithm is the power to which a number must be raised in order to get a specific value. Now, looking at just that, that's confusing to understand. Let me give you an example. 8 to what power, in this case 2, gives us 64 is basically what that is. So basically what a logarithm would help you is if we had, say, 8 to what power gives us 64, we can actually use logarithms to figure out what that is. And a better example would be, say, 2.4 to what power gives us 179 or something like that. Because this one we could figure out. This one we are not going to be able to figure out in our head, but logarithms will help us figure that out. Okay? In this case here, 8 is considered to be the base. And the base cannot equal 1 for logarithms. It just won't work. Okay, and then 2 in here is the exponent. So 8 to what power gives us 64. We can figure that out with this different form, which says log base 8 of 64 equals 2. So 8 to the second power gives us 64. Okay? It'll make more sense as we continue on in here, I believe. A common logarithm always uses 10 as their base number. So, for example, 10 to what power gives us 1,000. 10 to the third gives us 1,000. We can write that as log base 10 of 1,000, and that equals 3. Now, if you can actually, since a common logarithm always uses 10 as its base, if you can actually leave the 10 out of the base here. And so if you don't see that, if you just see log of 1,000, so you know that that's log base 10 of 1,000. So if you don't see the 10 down there, that means it's written there. Kind of like if you have x plus 4, you say how many x's do we have? There's one x out there, right? So it's kind of the unwritten piece there. So if you don't see anything written down there, then that means it's got to be base 10. Okay. Let's see, evaluate the logarithm without using a calculator. So log of 10,000. So really what we know is that this is 10, right? And we want to figure out what this equals. So I'm just going to put this. This is log base 10 and x. So now I know that if I've got log base something of some number equals another number, I know it's going to be, what they're saying is 8 to whatever the number, the base number times whatever it equals, 2 the base to that power, whatever it equals, gives us this number. So what this is saying is 10 to what power gives us 10,000. Okay? And so that means that x has to be, because basically, I don't know if you remember this or not, but 10 to, like basically there's 1, 2, 3, there's 4 zeros. So that means 10 to the fourth power will give you 10,000. Okay? Okay. This one here, log base 10 of 1 over 100 equals x. So what this really says is 10, sorry, gotta get rid of, there we go. 10 to what power gives us 1 over 100. Okay, so now since we've got 2 zeros, but they're on the bottom, that means those are negative. So that's, oops, that means that x has to equal -2. And just to prove that to you there, 10 to the -2nd power gives us 1 over 100. Okay? Okay, now we're going to now do the rewrite exponential equations. Okay, so we've got log a equals c is the same thing as a equals 10 to the c, because if you'll remember, that's got base 10, but that's usually not written there, so that's why I specifically wrote this without it. Okay, so that 10 comes from right here. Okay, and then obviously there's the A goes there and the C goes there. So it says write a logarithmic statement for each exponential statement. So here's how I like to think of this. This 4 here, that's this number here. That wants to end up being in this spot here. So I think of this. This 4 wants to be where the 10 is. So the 4 pushes the 10 underneath over here. So it's going to equal 4. And then we've got log, and this 10 ends up being the base number, but so we could write log base 10, and then the 10,000 stays right where it's at. So you could write that, or it's really probably better without the base 10. So log 10,000 equals 4. I know you're like, what the heck does that even mean? So remember, 10 to what power? 10 to the 4th equals 10,000. So just to show you, we're going to go over this in more detail later, but if we do log 10, that's 1,000, there's 10,000, push equals, and we get 4. So look, log 10,000 equals 4. Okay, this one here, same idea. The 1 pushes the 10 down underneath, so we get equals -1. This 10 goes down here, so it's basically log base 10, but we don't have to write it. So log of 1 over 10 equals -1. Okay, and I can show you that one too, just for kicks. So we can do log of 1 over 10. Oops, go over, close our parenthesis, push equals, and there's our -1. Okay. Write an exponential statement for each logarithmic statement. So now we're going to convert the other way. But before we do that, let's take a quick little comedy break.
Hit it. What are you doing?
Okay. Only thing I can think of was that first dog is that he couldn't see the ground or something like that, so he's having a hard time figuring out that one was funny. Anyway, sorry. Write an exponential statement for each logarithmic statement. Log 100,000 equals 5. So I'm going to put my base number in here, and so I simply know that this means 10 to the 5th power has to equal 100,000. All right. Same thing here. Log base 10. 10 to the -2nd power equals 1 over 100. Okay, and that's all you do to switch from logarithmic into exponential and vice versa. Okay, all right. If you have any further questions, please feel free to ask. Thanks.